Yeah, hi everyone. So we covered a lot of topics in our prior videos, in my prior videos, and till class 10, I have tried to clarify many trigonometric. If you talk about trigonometry, I have tried to cover many things, but there is one thing in trigonometry which students are very scared. I know that is trigonometric identities. Now, identities, I find it the most easiest. It's the most less time taking, and you will get one identity, trigonometric identity, in class 10th examination. So, how do you resolve this? I have put 4 trigonometric identities on the board with which we are going to solve today. So, the basis is, I'll start with 0. First is Pythagoras theorem is the basis of all identities. What is an identity? It is an equation. An identity is an equation which is true, and it holds true for all values of the angle sine. If A is the angle, it holds true for anything. You put A as 20, sec 20, 1 minus sec 20, sine 20, sec 20 plus into, whatever, say sec 20 plus tan 20 equal to 1. That will always be 1. So, the basis is Pythagoras theorem. What is Pythagoras theorem? I'll start with the basics. This is theta, this is P, this is base, this is perpendicular. It says this is base, this is hypotenuse. B square plus P square equal to hypotenuse square. Now, let's do something. What is B actually? B is, say, PQR. We'll put X, Y, Z. X, Y, Z. Base is how much? Base is YZ square by base is YZ by XZ whole square plus perpendicular is XY by XY square by hypotenuse is again XZ square equals to hypotenuse is XZ square. Clear so far, right? Now, YZ by XZ, sorry, I put base is YZ, yes, base by perpendicular, this is YZ by, fine, that's fine. Now you take LCM as XZ square. Now sine theta, try to extract sine theta from here. Sine theta is XY by XZ. So this is nothing but, this is, you try to understand, base, I'm sorry, see, base is simply YZ only, right? YZ square plus P is XY into XZ square. Now, this is the equation in terms of the sides. Now, if you divide everything by XZ, you are dividing this by XZ square. So this becomes YZ by XZ whole square plus XY whole square by XY by XZ whole square, and this becomes 1. And YZ by XZ is YZ by XZ is cos square theta, right? Cos square theta, and XY by this is sin square theta. So this is the first identity we derive, and with the help of this you can derive another 2, that is 1 plus tan square theta equal to sec square theta, and 1 plus cot square theta equal to cosec square theta. So these are the 3 identities which you have to use to derive prove other identities. So the questions will not come as prove cos square theta plus sin square theta equal to 1. No, it will assume, the question will assume, the examiners assume that you know all these 3 formulas. Today I showed you how to derive cos square theta plus sin square theta equal to 1. You apply Pythagoras theorem. apply and you divide by the hypotenuse, you get cos square theta and sin square theta, and then equals to 1. Now how do you derive this from this? In my prior classes I have told you, you divide both sides by cos square theta. So this becomes 1, sin square by cos square theta becomes tan square theta, equal to 1 by cos square theta, that is sec square theta. Similarly, if you divide by sin square theta both sides, this will become cos square by sin square theta, cot square theta, cos square plus cos square 1, and 1 by sin square theta is cosec square theta. So now we are going to use these three and resolve these identities, prove these identities. Let's move on then. Now there are other inputs which you can take. One is tan theta equal to sin theta by cos theta. Cot theta is cos by sin. This all cosec theta equal to 1 by sin theta. Sec theta is equal to 1 by cos theta, and cot theta equal to cos 1 by tan theta. 1 by tan theta. Now remember all this. Remember this, and other inputs are these three formulas: sin square theta plus cos square theta equals to 1, 1 plus tan square theta equal to sec square theta, 1 plus cot square theta equal to cosec square theta. Now using these three and these 5, you have to prove each and every identity. So let's move on to number 1. Left hand side, you always have to prove that these first three are proof. This one, this one, this one, and this is asking evaluate. This is all from your NCERT books, so this is, you'll find it in other books too. Now LHS, if we so the basically what is the, before proceeding, I would like you to understand that you have inputs, 5 inputs, these 5 formulas and these 3 formulas, identities. These are also identities, these are expressions. Cot is inverse of tan, sec is inverse of cos, but basically everything can be broken. You know, tan can be expressed in terms of sin by cos, cot can be expressed in terms of sin and cos, cosec can be it can be written as 1 by sin, sec can be written as 1 by cos, cot can be written as 1 by tan or sin by cos. So break everything, try to resolve the problem by breaking. I am writing this very in breaking, this is important, into sin and cos. That's the basic, sin and cos. So sin and cos using these 5, and then apply all these formulas. This is one of the basic. Not all problems are resolved by this, but most of the problems get resolved with this one. Okay. So now let's move on and solve these problems. First one, left hand side equal to, break everything into sin and cos. Sec theta 1 by cos theta, 1 minus sin A into sec A 1 by cos A, and this is 1 by cos A plus tan A. I broke everything. No, tan A also has to be broken cos by sin. and resolve it. It's as simple as that. So basically this formula also gives you another formula, not a formula, 1 minus sine square theta equal to cos square theta, and 1 minus cos square theta. If you move cos there, then it becomes sine square theta. And similarly if you move 1 here, tan square theta becomes sec square theta minus 1, cos square theta becomes cosec square theta minus 1. So similarly I'll put, if you move 1 on that side, tan square theta equal to sec square theta minus 1. This is just a movement of the variables or the ratios here and there, and sec square theta minus tan square theta equals to 1. Don't get confused, I'll clarify. Okay, so this is done. Now try to resolve this. This is very easy. See, 1 into 1 is 1. You take an LCM here. 1 minus sine A by cos A into 1 by cos A into 1 sin A plus cos A sin A into 1, I broke this tan into cos by sin, sin by cos, sin A by cos A. Take the LCM, 1 plus sin A by cos A. I hope this much is clear. You just broke this into sin and cos, sec 1 by cos, 1 minus sin A, 1 by cos A. Break everything into sin and cos. Done. Using these 5 you can apply anywhere. So oh, this didn't had anything, right? 1 minus sin A by cos A. Why did I write this? Oh, it was there. Sorry, that is the reason it's there. Okay. Now let's move on. 1 by sin A by cos A. But where is this? Why is this cos? This is not required, right? I don't know why I am looking two equations actually. Fine, this is fine. 1 minus sin A. Okay. 1 minus sin A by cos A, 1 plus sin A by cos A. A minus B, A plus B. Always you will get this formula. A minus B algebra is equal to A square minus B square. So 1 minus B, 1 minus this is equal to 1 minus sin square theta, sin square A by cos into cos is cos square A. 1 minus sin square is cos square, and cos square A equal to cos square A 1, that is equal to right hand side. Hence proved. This is what you need to write, hence proved. So this is the first problem, which is very simple. I'm looking at the board, this angle from this board is actually I'm looking at many stuffs. In book, copy and book it's a lot easier. So again I'll explain. Sec A is 1 by cos A, break everything. Sec A is 1 by cos A. It's all multiplication. Here it's multiplication, here is multiplication. You take LCM. This is not LCM required. You take LCM here. And then 1 minus A minus B, A plus B is A square minus B square. 1 square is 1 minus sin square A. 1 minus sin square is cos square A. They cancel with each other and that's equal to 1. Let's move on to the next one. This one. Similarly, as I told you, break everything into sin and cos. Good so far? Take LCM. Cos A minus sin A cos A. Cos A plus sin A cos A. Good so far? I simply broke cot A into cot by sin. Cos will remain as it is, and that is all. I took LCM here. So another thing, you know that, right? A by B by C by D is A by B into D by C. It gets reversed. So that is what is going to happen. This become, I'll take cos A common here. I'll not take it common. Let's see what happens. So by sin A, so that I'll make you decide that why we'll take common. What is the need of the hour? Now sin A and sin A gets cancelled, but we have to represent it in form of cosec A. So that means, that speaks that we should get sin A somewhere, sin A, 1 by sin A. So that's the reason we see that we have a sin A cos A here, extra cos A. We have an extra cos A here too, and then we will be left only with sin A. I don't know if I will be able to reach this, but that is the correlation. So that is why I take common cos A here, 1 minus sin A, and I take common cos A, that is 1 plus sin A. Cos A gets cancelled. Now you will say, depending upon the problem, you see I have reached till cosec A. Now sin A can be very easily written as cosec A, 1 by cosec A. So this becomes 1 by cosec A, and this becomes 1 by 1 plus cosec A. I'll take LCM cosec A. Cosec A minus 1, cosec A plus 1 by cosec A. I break everything into cosec A because I need to prove this. It's not because of because basically everything has to be taken into sin and cos. But since once I reach this point, 1 minus sin A by cosec A, and I'm very close. I know sin, if I inverse it as cosec A, I can very well, I think I can prove. So the denominators cancel, and we are left with cosec A minus 1 by cosec A plus 1, and that is equal to RHS. Proved. Hope you understood. Okay, let's move on to the next one. Third one. So third one says what? Sin A minus cos theta plus 1, whatever. Let's see here, this is already simplified into sin and cos. Here it's in tan. So let's pick up RHS first. RHS, not to complicate things, and break it into sin and cos. Tan theta is sin theta by cos theta. Sec theta is 1 by cos A. Sin theta by cos theta plus 1 minus 1 by cos theta. Take LCM. Sin A, sin theta minus cos theta plus 1. Sin theta, I take LCM as cos theta, sin theta plus cos theta minus 1. The denominators cancelled and you are left with what? On the you are left with the left hand side, LHS. The only thing which you did was picked RHS first, and you reached and broke into sine and cos. Most of the problems will get resolved if you break into sine and cos. But here, since it is already into sine and cos, let's break this one into sine and cos and reach here. Okay. Now there can be, if you want me to pick up RHS and move to LHS, that can also be done, but we will not do it today. Let's move on. If you want me to show that, you can put in the comments box. I can definitely provide you with the written expression. The fourth one, what is that long thing? How do I determine the value? I would say again, they break this into sine and cos, everything. There is no LHS, RHS. Let me break. 1 plus sine theta by cos theta, 1 by cos theta, into 1 plus cos theta by sine theta minus 1 by sine theta. Using again and again, I am saying these 5. These are 3 inverses. Cosec is inverse of sine, sec cos, cot sec, tan. This is not required even in breaking. This is not required. Only these 2 you remember. These 4: tan theta, cot theta, cosec theta, sec theta. Now take LCM. So now here is now I am not able to solve. This is where you will get confused. You will think, such a complex thing. What do I do next? Now there is, whenever you see such a formula where you have a plus sign and you have everything, almost everything the same, only there is difference between sine and cos. So try to bring it in this format. So I can do that, right? I can group this one together and this one together, because this is a square minus b square. So this is cos theta plus sine theta plus 1 by cos a, sine theta plus cos theta minus 1 by, I can put sine a cos a. Sine a cos a. Now a plus b, this is a, this is a, this is a, and this is b. A plus b into a minus b is a square minus b square. So it says cos theta plus sine theta whole square minus 1 square, that is 1, a square minus b square, right? A was sine theta plus cos theta, a square minus b square, a plus b, a minus b is a square minus b square, sine a cos a. Now apply a plus b whole square. Always whenever you see a cos theta plus sin theta whole square, you apply a square plus b square plus 2ab, a plus b whole square is equal to a square plus b square plus 2a. So what will become? Sin square plus cos square theta will become 1. That's the reason we are breaking it into a plus b whole square. So a plus b whole square is cos theta plus sin theta cos square theta a square plus b square plus 2ab and minus 1. I am writing theta somewhere and a somewhere. Anyways, whatever, right? There is no difference. Okay. Anyways, sin square theta plus cos square theta is how much? This is 1. So this becomes 1 plus 2 sin theta cos theta minus 1 by sin theta cos theta. This gets cancelled. 2 sin theta cos theta by sin theta cos theta, and that is equal to 2. That is the answer. So this is equals to 2. I hope you enjoyed today's class. Please let me know if you have any questions. Thank you so much for watching my video. Please do like, share and subscribe, and let me know if you have any questions. Thanks so much. Have a nice day.